My name is Stas, and I am lead technical artist in Plarium, in our Ukrainian studio in Kharkiv. And we are going to talk a little bit about Raid Shadow Legends, and especially about optimizing graphical performance on this game. So you probably want to know... Oops. You probably want to know who am I and what Raid Shadow Legends is. By the way, who of you played this game? Okay, at least a few people actually played it. That's kind of cool, but for everyone else, I will need to introduce the game. And yeah. But the purpose of this talk is talking about GPU optimizations. And as you can see from previous slide, we don't have actually any graphical programmers in our team. And believe me, it's hard to find graphical programmer in Ukraine, especially with some experience in Unity. So yeah, so that's kind of our situation. And yeah, so what RAID is?
Get ready to raid. Explore and fight. Choose your champions. Defeat bosses. Win PvP battles. Raid Shadow Legends.
Okay, so there was our trailer, and as you could understand probably from it, it's a hero collector RPG. And it's a pretty crowded genre right now, and it was crowded like 3 years ago when we started working on the initial prototype. And yeah, and we needed something to stand out. And for us, that quickly became an idea that we needed to have realistic style to our game, and we wanted it to have that dark fantasy feel to it. So yeah, that was our focus from day one. And yeah, ideally you want more than one way to stand out, but for the purpose of this talk, this is the main one. We have also some gameplay differences and stuff like that. And all of that seemed to work for us, because we have around 7 million downloads on 2 platforms right now, and 500K active players. And people spend 30 minutes per day, our users spend 30 minutes per day playing Raid. And we've been featured multiple times on Apple App Store and Google Play Store. So I guess something went right for us with this project. Yeah, unfortunately, I cannot talk about everyone, but I can at least introduce to you to technical art team, since it's a technical art talk. So yeah, I look terrible on this picture, but my team looks nice. And yeah, that's the whole purpose of game development. You cannot do anything by yourself. You need a team, at least a few people. And we have a huge team working on Raid, and the technical art team is only a small part of that story. Yeah, and to understand a little bit better what we're going to talk about next, here is our typical battle screen. Our main focus is characters, because it's a hero collector game, and characters need to look good, they need to look great. You collect them, you fight with them, you upgrade them in different ways. So yeah, everything is centered around characters. And from optimization standpoint, most important part of this screenshot is actually environment, because it takes a lot of time to render, just simply due to the fact that it fills the entire screen. And yeah, so environment shader optimization was for us one of the main things that we needed to do. And yeah, and it's realistically styled game, so you want your lighting and shadows look somewhat decent, and we will talk about that a little bit. And yeah, it's a fantasy game, so obviously you need a lot of spells, effects, and stuff like that, and we spent a lot of time making that. And yeah, so we're gonna talk like a little bit about VFX creation and VFX rendering. And effects generally look terrible without a bloom. And so, yeah, so we will talk a little bit about the bloom and the post-processing in general. Okay, and for the purpose of this talk, we will mostly use Xcode screenshots. By the way, you don't need to take pictures of this, because I will have a download link to this presentation in the end of the talk. So, yeah. This is taken on iPad Air 2nd generation, so I guess it's 4-year-old, 5-year-old device, and we target 60 FPS on that. It can dip below that, but generally it's good enough for 60 FPS. I would like to talk with you with some Android examples, but unfortunately or fortunately for the demonstration of stuff, Xcode is just a lot better than the Android tools, in my opinion. I will talk a little bit about the Android situation a little bit later. Yeah, and the other important tool that I want to mention is Unity Frame Debugger. Sorry. Yeah, it doesn't give you any kind of profiling information, but in our team, I find it useful to remind about its existence to developers and to people who generally just write code tend to forget about it. And it's important to know what's going on in your game in editor. It's especially useful for profiling or fixing issues with draw order if you have a lot of transparent objects and forward rendering, and you can mess up your draw order in some ways, and Frame Debugger is good for fixing that, or to understand it in your problem at least. And I use it a lot during the VFX review, because you can see a lot of stuff like overdraw that's important for performance. So don't forget about this simple but useful tool. And first thing that we are gonna focus on is environment rendering. As I told you before, it fills a large screen area, basically your entire screen. And it introduces some overdraw while doing that, because, for example, these barrels are situated on top of the ground plane, so you need to draw the ground plane, after that you need to draw the barrels. So yeah, so you probably draw in a lot more pixels than your full screen. And yeah, and like any environment shader, you want it to support texture blending. It's a simple thing. You can see it on video. It's many ways to implement it, but yeah, but we need it for environment shader. And due to that fact that it fills a large screen area, it has highest priority for optimization. As you could see from our battle screenshots, everything else takes a lot less space. Yeah, and it can be used in different variations. So you can use it with 3 textures. You can use it with 2 textures. You can use it with light maps. You can use it without light maps. And you could write a different shader for each and every case, but I find it, but sometimes if you have a 3-texture blend shader, it will look fine with only 2 textures. And artists will do that to you. So you kind of want to limit their freedom in some ways. So we wrote it as a single shader. Yeah. And yeah, this is a screenshot from GPU snapshot from iPhone X. Total frame time is 6 milliseconds, and environment took actually 32% of it. Who of you knows of this functionality of Xcode, like this chart, and knows what it, wow, a lot less than I thought. So yeah, that's a new feature. Apple introduced it like a few years ago, probably 2 years ago. And this pie chart actually shows you how much time you spend in doing different stuff in your shader. And you can, basically for every shader, it provides this information for you. So in our case of optimized environment shader, the most time is just arithmetical instructions. Yeah. And you obviously need to read more than one texture in the shader, so you will you will have some memory stuff going on, and etc. And yeah, and this pie chart is only available on latest devices. I do believe that from iPhone, so you need at least iPhone 8 to show that. Okay, so and sometimes optimization starts before you actually render something. Who knows what SHADERGUI is? Okay. So yeah, it's useful for, it's basically inspector for a shader. You can write inspector in Unity, but you can write inspector for shaders, and it's useful for in many ways. You can do buttons, you can do custom controllers, and you want that. It makes your life easier. And another way to make your life easier is this example. It's example of SHADERGUI of our environment shader, and you can check by doing this simple thing if your textures have alpha. And if they don't, you can compile a simpler version of your shader using enable or disable keywords instructions. So yeah, it's simple, but it's effective in terms of you don't create unoptimized materials. You if you don't need to use complex blending, because textures need to have alpha for that, you can disable it in your shader and just strip that code. So that's one way you can use SHADERGUI. Yeah, and the main point, or one of the main points of environment optimization is actually shadow optimization. Because typically shadows, I'm sure many of you know that, but just to recap, typically shadows need to calculate, shadow maps, you need to calculate a lot of stuff. Well, you need to render depth texture from your light, you need to, and after that you need to depth test the texture, and that's actually done in shadow receiving shader typically. And in our case, that shader fills like entire screen, and you basically need to do that additional calculation for every pixel of your screen if you use typical approach. Yeah, and for shadow to look nice, after that you need to do some filtering. So, and that's also typically done in shadow receiving shader. So yeah, and when you add that all together, that's a lot heavier than actually drawing the environment textures. So yeah, but in our case, we have a few things going on for us. And in this talk, I would like to encourage you to, if something doesn't fit your needs, if Unity doesn't fit your exact needs in some way or another, you always can write your own stuff. And we've been able to do that, even not having dedicated graphical programmers, just by doing technical art stuff or using technical art team resources. So, yeah. So what is going on for us? What's going right for us in case of our rendering? We have a limited number of shadow casters. We want our characters to cast shadows, and that's basically it. Nothing else in our game casts dynamic shadows, and it's totally fine for achieving the look we want. We can use low shadow resolution, and we have a controlled environment, so we know exactly what characters on the screen, what characters are available to you, what characters you will see on next screen, and stuff like that. So it's extremely controllable. You cannot look far, like in FPS game, and Unity shadow system is suited to work in FPS. So yeah, and you don't need shadow cascades, for example, in our case, because we're always looking to characters from same distance. So yeah, so our solution is to use shadow mask. This is actually based on a plugin from the asset store, but last time I checked, it was not available anymore. So I just will talk. We modified it heavily, but I will talk through what it does actually. So we know that environment can receive shadows, like basically our ground plane can receive shadows, and characters can cast shadows. And for that to work, we don't actually need any depth testing. We just render the mask of our characters into a separate render texture, and this can be small. After that, we can do any kind of blur algorithm to that you want, because the texture is small, and it will be a lot faster than doing it for entire screen, and you don't need to take any depth stuff into account while doing that. And after that, you just multiply your environment shader by the texture, or in this case, inverted version of the texture, and here you have your shadow masks, shadow maps. So yeah, and that's a lot faster than doing it the normal way. I will, depending on the device, but I will say that it's at least 5 milliseconds faster than do it normal way. On our target devices, that's around iPad Air, probably first generation. So yeah. Yeah, and that's the screen that showcases our shadow mask rendering, and it's basically 2 milliseconds on iPad Air, and it's like 5 years old at this point. And why I test that on iPads, because they have a larger screen than iPhones of same generation. So in terms of rendering speed, they will be slower. Yeah. And next thing that I will talk about is character rendering. And this thing is slow, but it's fine with us. You want to pick your fights. We have a big team. We have a lot of people working on this game, but we still need to choose on what things we need to focus. So I will quickly tell you about our approach to character rendering and character shader. So yeah, this is how it looks on mobile, and it's PBR. We, by the way, use the old Unity, because the project is 3 years old, literally. So when we started, there was no lightweight rendering pipeline, no universal rendering pipeline, and stuff like that. So yeah, but the main principles that I'm talking about are going to work in any render pipeline that you choose. Okay, so it's PBR, and our initial approach was to write a surface shader, Unity surface shader, and to modify it to suit our needs. It was fine for organizing texture channels the way we want, but its surface shader in Unity is kind of black box in many ways. Well, you can read actually all the CG include files, but it takes time. They are not organized very well, and you don't know exactly how to modify it to suit your needs in all times. So our approach was typical technical art approach, I would say. But we took a ShaderForge PBI shader, and that actually uses a vertex fragment shader. We stripped everything that we don't need for that, and yeah, and added the stuff that we actually needed. And we needed the shader to support various effects. We needed it because it's a fantasy game. You want your characters to burn and to freeze and stuff like that. So we needed it to support effects like this one or this one. And yeah, and you want to do it in one shader if you can. So it uses multi-compile to achieve that. Yeah. And yeah, but as I told you, this is quite slow because it's PBR in least optimized way possible. Well, we stripped a lot of stuff from typical PBR, but it's still slow. So yeah, as you can tell from this screenshot, it takes a lot of time on iPad Air first generation. And yeah, and it shows like it's 30 FPS still, but frame time shows 35 milliseconds, and that's less than 30 FPS. So we probably need to optimize that. But iPad Air is really slow. Like, it's really old and really slow by this point. So our solution for that was to adjust device settings. So we have a graphics selector in our game. People can choose between 4 different options. And this is the normal preset of this and the same screen. And it's 16% faster than Ultra preset that you could see on previous screen. And yeah, and for such device variations as we have right now, you probably want that in your game as well, if you want to support a big audience and in the same way achieve good graphical results. Yeah, and the same screen on iPhone X, not the latest iPhone 10. The entire frame on Ultra settings takes like 10 milliseconds. It's more than good enough for 60 FPS. So the difference, as you can see, is huge. And yeah, and by profiling it on different devices, on iPad Air, you don't have access to this pie chart. And it's useful for many different reasons. So yeah, you want to profile your game on as many different devices as you can. And yeah, and in this case, character shader is actually not the slowest thing at all. So if you needed to optimize this game for iPhone X, you will need to focus on different things than while optimizing it for iPad Air. Yeah, and as you could probably see, we have some kind of shadow maps for the character screens like this one. Yeah, and for that to work, we actually needed to add all the depth testing stuff to our game to introduce it back, and it's totally custom, and we need to support it. So yeah, so I just want to warn you, if you go the route with overwriting like basic stuff like shadows, you will probably spend some time supporting it. But in our case, it's pretty much worth it. And one last point about the character shader is you want to be especially careful with your shader features and multi-compile instructions, because only one part of we need to optimize it for many different reasons, and one of that is build size or bundle size. So yeah, and shaders tend to get really huge really fast if you use too many multi-compile instructions. It's basically something like geometric progression. The exact math behind it is available on Unity blog. If you're interested in exact math formula, you can look up it there. But I can tell you that getting rid of 3 multi-compile default Unity multi-compile instructions marked here with red and replacing them with only one define that we actually need help us to save like 1 megabyte of bundle size. And that's 1 megabyte is a lot. Okay, and the next thing that we will talk about is visual effects. And yeah. The main enemy of visual effects, at least in our case, is overdraw. As you can see from this screen, lava particles took like 3 milliseconds to render. Other particles took at least 6 more, and as a result, total frame time went up to 20 milliseconds, which is a lot more than 16 milliseconds we need to run on 60 FPS. Yeah, and from this rendered frame, you would never tell that the lava particles is actually so huge. So yeah, and they actually use quite a heavy shader on them. And yeah, and that's a bad example. You don't need to do stuff like this. But you probably want to do it like this. Yeah, blades, it's a similar effect, but blade rendering took less than 500ths of millisecond, and yeah, other particles took like 4 milliseconds or 3.5, and total frame is 13 milliseconds. So it's more than good enough for 60 FPS. Yeah, and it still uses particles, but the overdraw is a lot less, and yeah, and that's good enough to work for us. Yeah, and the other curious case of overdraw is effects like this. So you probably, well, it's a few main ways to achieve rain in our game, and you can do it with just a plane with pen and textures in front of your camera, or probably in a little bit more fancy way with cone to make it directional. But yeah, but we quickly found out that actual particles look better, despite all of our tries to make it with planes. Actual particles look better, and our approach to that is not to use Unity particle system for this, because you need a lot of particles to make a believable rain, and you probably don't want your CPU to deal with that, but to write our custom vertex shader for this to work. And what you can do in vertex shader, well, first thing you need to do is to create a custom mesh. You actually can pre-bake it ahead of time. In this case, we pre-bake it. It's basically a huge number of quads, like 10,000s. Takes 10,000s of quads that you create ahead of time and store in your bundle afterwards. And you need to write some values, custom values in each of that quads. For example, you write for each vertex, you need to write its center. So each vertex knows where the center of his particle is. And you also want to have some random values in shader. You can generate pseudo-random in shader, but you can just write some random values into your UV coordinates, as in this example. And when you have some random values in shader, you can do a lot of stuff with that. Like some particles needs to have different lifetime. And yeah, and we just use LORP between two global values and one random value. And yeah, and you want particles to have different speeds, the same approach. Yeah, and this is how it looks. Yeah, the snow is slower, so it's better. It looks better on video. But yeah, you can clearly see that this is a 3D effect and not just a plane in front of the camera. Yeah, and this video is basically away from our upcoming PC version, so it has a few fancy effects. Yep. Sorry? Okay. And yeah, and why do we want bloom? It's because of this. So as you can see, the only difference between these two screenshots is that on the left one, the bloom is off, and on the right one, the bloom is on. And as you can see, the left one looks terrible, and the right one looks fine. So yeah, so we really wanted to have bloom for our effects, but we never needed it for anything else. We just wanted for the effects, and that's it. And yeah, and we can use really a low resolution buffer for that, because bloom works fine. It needs to be blurred a lot. So yeah, so you can get away with low resolution buffer. This screenshot is to scale, so I don't know. It's fourth of the screen or something like that, or probably even less, or third of the screen. So it's low resolution. And we can manage without depth testing for bloom. If it will shine through some objects, in our case it's fine, because we don't have any walls in front of the camera. We always see characters and effects, so yeah, so if in some cases something obstructs your bloom, let it shine through it. We're fine with this. Yeah, and in forward rendering, at least, and bloom needs to be drawn after everything else. Like normally it's done like you draw in just a full screen quad, and after that additively apply your bloom texture and render it that way. And that is, well, that's also slow. And yeah, so how we can optimize that? I actually came up with these ideas especially for this talk, just to have an interesting point to talk about. But yeah, still. As you can see, in our typical screen, we have a lot of black. And when you use additive blending, the black is basically 0. You will not see it on the final screen. But you still need to wait for all that stuff to be released before you can actually draw bloom, because every black pixel will wait for underlying pixels to be released, and yeah, and that's why the bloom, just apply an additive path of bloom is really slow. So the basic idea is not to use one quad, but to use an array, well, a lot of quads. We create it on enable or on awake, I don't remember. So each quad in this mesh is unique. They don't share vertices. So yeah, and by doing that, you can do some interesting stuff in vertex shader. Yeah, in here you just in this example, we just write the coordinates of the quad to each vertex of the quad. So each vertex knows where exactly it's located, it's quad located. And after that, we can do a few, in this case, 5 textual lookups in vertex shader. It will not work on OpenGL ES 2.0, but in 2019, I guess it's fine. So by doing that, we can determine if this quad is entirely black or not. And if it's black, we can just move it to 0 coordinates. Basically, move it off screen and make it take a 0 screen area. So yeah, and this is how it looks in game. As you can see from these debug views, it introduces a lot less overdraw. And you don't need to wait for every pixel of the screen to be released just to draw your bloom. And it's depending on the screen, this solution is 10 times or more than that faster than normal bloom. So yeah, it basically depends on how much bloom do you have. And yeah, you can easily get rid of if instruction here if it bothers you, but there is worse. It's so simple it was not much point to do that. So yeah, but it's still doing all that in vertex shader is actually a lot of faster than waiting for each and every pixel to be released in fragment shader. So yeah, and we can use bloom or this path for doing other stuff. For example, we can use it to achieve something like volumetric lighting in this screen. We just render our tubes or light tubes with bloom camera, but not render it with a main game camera. And by doing that, we achieve something that looks like blurred volumetric lighting. And yeah, and one last point that I want to talk about is Android profiling. I can recommend 2 tools. it's a Snapdragon profiler because it has a functionality of GPU screenshots and stuff like that. But I couldn't manage it to work with our game because it's a little bit finicky. But I'm pretty sure you can manage it. You can make it work with your game. And GAPAD is a tool that was initially available in Android Studio, but now it's separate. And it basically like more fancy version of frame debugger that runs and you can debug stuff on your device and get a lot of useful information for that. But JPID doesn't have any profiling information and doesn't tell you everything about your FPS or milliseconds and stuff like that. Yeah, and one last point about VFX is our approach to creating VFX, and we try to create mega shaders. Like we try to make like one shader that can do it all. And yeah, and in some cases it works, but we found out that it's better to have simple shaders, like that do simple stuff that everyone understands. And by doing that, it's more likely that your VFX artists will actually use it. Probably it's our problem that we didn't write our mega shader in a good enough way and didn't make it good enough to understand, but still. Yeah, that's approach that we're using right now. We're writing simple small shaders that do one thing, but do one thing good enough. Yep, and we made this game, and it's pretty successful, but as you can tell, we are definitely not perfect, and we could not optimize everything, and we don't have people to do some stuff. So, yeah, we are definitely not perfect. And some things went wrong for us. Frame drops can occur on different devices for different reasons, and some effects need optimization. And you can find more than a few places with notable lags in our game. Our VFX shader workflow can be optimized because we have a lot of VFX shaders for different reasons, and we can like strip half of that. And character shader can be optimized. But some things went right for us. Most people seem to think that our game looks good, and I tend to agree. It runs on most modern phones and runs good enough. Graphical performance is acceptable. In fact, we rarely have issues directly related to graphical performance. Some parts of our game are decently optimized, like environment shader and bloom and stuff like that. And we have tons of content. We have like more than 300 heroes right now, and we need to have VFX for each and every hero, so it's tons of unique VFX and stuff like that. And it was critical for our game success. And the game is successful. And Apple seemed to agree. They even used screenshot from RAID on their latest new iPad Air presentation materials. So yeah, and the RAID runs on 120 FPS on iPad Pros with 120 Hz screens. So if the players want it, this option is available for them. Yep, and this is obligatory screenshot. If you find the things that we do interesting, you can look what job openings we have right now. Yeah, and if you have questions, you can ask them now. If you don't have questions but still would like to download the presentation, here is the link. There are two mics back there in the middle of the room, so please.
Hello.
Hi.
Thank you for the talk. I would like to ask you how do you exactly draw the shadow mask? Is it like a separate camera that only renders characters?
Yeah. So because we always knew the positions of our characters, we can position it like basically to render just our characters and nothing else. So we position our shadow camera based on character position, not the main camera position. And yeah, and after that we just render that to separate render texture. And yeah, so that's basically it.
Oh, okay. So I understand that when it comes to the bloom, this is the same story, but different layer and different camera, right?
Sorry?
When it comes to the bloom that you render,
yeah,
this is the same story, but different texture and different camera, right?
Yeah, yeah.
Okay, thank you.
Hey, you said you have 4 different presets for quality settings. Do you determine automatically which one to use on the device, or you let the user to use it?
Yeah, we try to do it automatically.
And how do you do it?
For iOS, it's easy, because you basically know about each and every device in existence, and you can just write some simple scripts that will check what device you're running on, and based on that, select a preset. On Android, it's more difficult. You can try to base it on GPU you're using, and we try to use some indirect indications like how much memory do you have on device. But when I get home, I probably want to rewrite the thing that determines graphical preset for Android. So I think a lot about this problem on Android, and yeah, I really want to have some kind of solution, but I don't have the good one yet.
Thank you.
Hi, thanks. It was a great talk. I just have one question about the bloom optimization. So, do you do the texture sample before you do any sort of blurring?
Sorry, can you say it again? I cannot hear you.
So, do you do the texture sample to determine whether or not the cell would be black? Do you do the texture sample before you do any sort of blurring?
No. Actually, I use the final texture for that.
Right.
I tried to use the low-res version of the texture before that, but I quickly ran into issue when it would cut pixels that are not actually black on the bigger texture. So you have to use the highest resolution bloom texture for that to work accurately. But my grid resolution of my quads I actually based on the smallest. To do bloom, you need to do downsampling first, and after that, you do upsampling. And by the way, you achieve blurring your bloom texture. And yeah, and I use smallest downsampled version that we use for my grid resolution. And by doing that, I get a better pixel to quad mapping. And by that, it's like you can pretty much be sure that your quads, if your vertices in the quads are black, is that the entire quad will be black.
Okay, great, thank you.
Hello. You told that you're not using the mega shader for VFX. You're using a lot of simple shaders. Do you know an approximate amount of unique shaders for effects that are used?
I think at least 100. As a lead technical artist, I want to keep that number low, but my VFX artist want to keep that number high, and we fight with each other.
Okay, thank you.
Hello. You mentioned your custom solution for rain, and as I understand, it's like custom GPU particles. Did you face issues with sorting transparency there?
In our case, no, because we basically almost always use it additively, and when you use additive blending, the sorting is not a problem. But you probably can fix that. I honestly don't remember if we fixed that or not, because we basically always use it in additive blending mode, and that's when you use additive, you don't have any sorting issues.
Okay, thank you.
Okay, if that's it, you can find me around here. if you have any questions or just want to talk.